Okay, so this is section 3.3, and it's recognizing horizontal lines and vertical lines and their equations. So take a look at a table here, which is the speed of a car. So this is basically identifying x as the hours, and then y is representing the how fast the car is going, miles per hour. So if we say that we're going 70 miles per hour, then the first hour would be, hey, I've gone 70 miles and within 1 hour. Then if I go to the next hour, I've gone another 70 miles per hour. So this continues on and on. So as you look at the table, you see all these points. They're all horizontal. And so we have a directional flow of y equal to 70. So this is our equation, y equal to 70, where y is always 70 and x, which is our time, is changing, but it's increasing from 0 to 6 and on and on and on. So this is a example of a horizontal line that's set up. And so let's take a look at the next page. Okay, here's some more examples of a horizontal line and its equation. So y equal to 3, again we go up to 3, where y is always 3 on this line. And so x is increasing or decreasing, but it creates this horizontal line. As well as when we look at this one, where y is equal to -2. So it's increasing on the x and decreasing on the x, but the y is always staying at -2. So let's take a look at the tables too for these two equations, just so we have that that common knowledge of that. Okay, so if we take and say that the equation is y equal to 3, that means that when you look at a table of x and y is always 3. See that? Always 3. And then if we look at the graph, it's decreasing and increasing. So we could have all these different numbers. So all of these correspond to a horizontal line. Okay, this is a horizontal line, as well as if we said y is equal to -2. So if we create another table, y is always -2, and x is increasing and decreasing. So let's say that's -2, -1, 0, and 1. So increasing in the negative direction and increasing in the positive direction for x, but y is always staying -2. So that's why we have another horizontal line. And so the general form of a general line is what we call y equal to b, where b is your y-intercept, but that's the equation, because generally if we did that, we would have mx plus b. But in this case, a horizontal line has zero slope. So that means that 0 would be in for the m times the x plus the b. And so that's why we don't really need this, because 0 times anything is 0, so we just get b. And so this is the reason why this setup is there, because the horizontal line always has 0 slope. Let's take a look at a vertical line. So let's go back to the book and see that as a vertical line. So we go to the next page. Okay, and we're looking at vertical lines. Okay, so here is a real world where we have time, and then this is our text messages. Okay, so we could have 1, 12. So for 1 month, we've had 12 text messages, or we may have another 1 month where we actually did 359 text messages. So we can see how we get a line that goes up and down, which we call vertical. So this is a vertical line. And so that means my equation is x equal to 1 because it's always staying at 1. And then we could have any number of different text messages for that month. And so that's why it's a vertical line. So here are some other examples of vertical lines that are x equal to 3. So all the values here, x is 3, but y, it could be either positive or negative on this line. As well as x equal to negative 2, we could have x, it's always x equal to negative 2 on this line. And so now y is either positive or negative along this line. But x always stays at negative 2. So let's take a look at the table here as well. So let's go to a table. And so if we look at this particular graph of x equal to 3, so we have x equal to 3. If we make a table, that means that for x and y, x will always be 3. And so if x is always 3, we saw in the table that y could be growing positively as well as negatively. So in this case, we're having, let's say, negative 2, negative 1, 0, and 1. So you can see as you plot these points that you get a vertical line, like we did in the graph you just saw. And so this is a vertical line. Alright, so it's a vertical line where x is equal to 3. And so this is another example of that. If we're looking at x equal to negative 2, again, x will just stay at negative 2. But y could be any number. So 2, 1, 0, negative 1. So these are increasing and decreasing for y, but x is just staying at negative 2. That's what they mean by x equals to negative 2, which creates a vertical line in this case. And so when we go to graph either the vertical line or the horizontal line, in this case, if we plot the x equal to negative 2, so here's negative 2, and I plot those points, negative 2, 0 is one of them, negative 2, 1 is another one, negative 2, 2, and negative 2, negative 1. So here is my line going in the vertical direction. Now, this one has a slope of no, undefined basically. So in this case, slope, which is m, is undefined because vertical lines do not have slopes. And the reason why is it's not slanted, and slanted lines usually are ones that have slope, and horizontal lines have zero slope because they're flat. It's completely horizontal, it's flat. And so when we have vertical lines, they're the only ones that don't have slope. It's called undefined. We don't say zero slope, we say undefined, okay, or no slope. Okay, but you cannot say zero slope in this case. And so that's important to see that. So again, when we're looking at problems, to be able to do that, we're going to probably be given some tables and then say, okay, what is that particular equation? And so that's important to be able to do. So if I was looking on page 197, problem number 41, okay, and I did a table of this, okay, and oops, it looks like XX, and I don't want that, so it's XY. Y. Okay, and so we have negative 2, negative 1, 0, 1, and 2, and then all the y's are 1. So again, is this a horizontal or a vertical line? Well, if you're not sure, let's just go ahead and graph them. Let's graph the lines. There's nothing wrong with that. I think it's much better when you graph that you see the visual effect. So here's negative 2, and it's 1. Here's negative negative 1, 1, 0, 1, and then we have 1, 1, and then we have 2, 1. And so we can see that, oh, this is a horizontal line, not a vertical line, it's a horizontal line. And so x is changing, but y is not. So this tells me that it has to be y equal to 1. And so that helps me to come up with my equation by looking at my data in the table as well as the data in the graph to help me come up with my particular equation. So that's pretty important to do in that particular case. So next we're going to be learning more about how to find perpendicular and parallel lines.